torque. So this is our loop. This is the magnetic field. So our loop is in the magnetic field direction. When our loop rotates by some angle, say 90 minus theta, then this angle becomes 90 minus theta. Let us see this. This is the loop. When it rotates by 90 minus theta, it makes this angle. So here, this is the loop. This is the loop shown like this. This is 90 minus theta magnetic field. The magnetic moment and magnetic field makes theta angle. Theta plus 90 minus theta is 90. This is A by 2. Now, the perpendicular distance of the forces F1 and F2. This is A by 2. This is 90 minus theta. Vertically opposite is 90 minus theta. This is 90. So it is theta. So this distance is A by 2 sine theta. Similarly, the perpendicular distance of force F2 is A by 2 sine theta. Hence, the torque is calculated as force into perpendicular distance A by 2 sine theta plus force into perpendicular distance A by 2 sine theta. This force and this force are equal, and they are equal to I. I is the current. Here it is given. Torque B I B A by 2 sine theta B plus B I B into A by 2 sine theta. On calculating, we get the torque equal to B I A B sine theta. So the torque depends upon following factors. The torque depends upon I, current, A, area, A into B. The torque depends upon B, magnetic field, and sine theta, the orientation theta. What happens when the orientation becomes 90 degree? The plane of the loop becomes perpendicular. What happens then? This is the magnetic field. The loop becomes perpendicular to the magnetic field. In this case, when this loop becomes perpendicular to the magnetic field, the theta becomes 0. M becomes in the direction of B. So therefore, when theta becomes 0, the sine theta becomes sine 0 and torque becomes 0. That is the minimum torque. So the minimum torque is when our loop is perpendicular to the magnetic field. At the same time, the net force is 0. The force acting on the two conductors are perpendicular. When the loop becomes perpendicular, the forces will cancel each other. when this loop becomes perpendicular, the forces cancel each other. Net force is zero. This is stable equilibrium condition. So the loop becomes in the stable equilibrium condition. Magnetic flux through the loop, in this case, it is magnetic flux is maximum number of magnetic field lines are passing. And there is a very important thing here, that this conductor is having current in this direction, so we magnetic field in this direction, so by using the magnetic field in this by the first finger, current by the middle finger, force in the upward direction. Now what happens after this? After this, does the force remain vertical? After this, the direction of the current changes and the force becomes downward, and the direction of the current, which was this, current was moving clockwise like this. After, when it become vertical, the current become again opposite. So this is done by the help of split rings provided in this simple electric motor. This split ring. In this diagram we see that these are the two permanent magnets. This is a coil and connected with the brushes and split rings. When this coil becomes vertical, then the split ring changes to the other brush, and the direction of current, which was from A to B, C to D, that also changes. Coil always changes its direction of current when the coil becomes vertical. So every half rotation, the coil changes its direction of current with the help of split ring. Yes, in this application, how to build a simple electric motor, it is shown, and there is a small classroom demonstration. This we have made at home, that this is a coil which is placed, self-made coil, and below is a magnet. So magnetic field and the coil, and this is a current source. Now when we supply the current, it must experience a torque and it must rotate. To make this electric motor, we should have first a coil. This coil is made up of a wire with insulation. This wire is having at least 10 turns in this coil. Second, a strong magnet. Third, two pieces of wire at least 8 inches. One end of these wire pieces are bent S-shaped, and the other end of these wire pieces are connected to a battery. Now, when the coil is placed on the stand, we see that the coil is free to rotate. The magnet is brought below the coil, and now we will connect the battery. When the current passes in the coil, let us see what happens. We see that the coil deflects and it moves like an electric motor. So this is the effect of passing current in a current loop placed in the magnetic field. You can also make this at your home. Here I have given the YouTube link. Thank you one and all for watching this.